Hello, today we will discuss impulse commutation technique, which is also known as class D commutation technique. Impulse commutation technique or class D commutation technique is like class C commutation technique that we have discussed in our previous video. Why it is like class C commutation technique? Because in both these techniques we are using a capacitor which is parallel to the two thyristors that we are using, that is thyristor T1 and T2. A parallel capacitor is actually used in both these techniques, so these are somewhat similar. The only difference between class C and class D commutation technique that in class C commutation either the thyristor T1 is on at a particular time or thyristor T2 is on. Both these thyristors never conduct simultaneously, neither they turn off simultaneously. That is, either the thyristor T1 is turned on and at that time thyristor T2 is off, that is non-conductive. If thyristor T1 is off, then at that time actually thyristor T2 was conducting, it remains on. In this commutation technique, that is class D or impulse commutation technique, both these thyristors will be turned off after some instant, and they never conduct simultaneously. Now we will see the working of this circuit diagram. Initially the thyristor T1 is turned on and the capacitor C is charged, having upper plate positive polarity and lower plate negative polarity. So the current from the battery flows through the thyristor T1 and load RL like this. Here the capacitor C is also act like a battery, and the current starts flowing through the thyristor, through the inductor L and through the diode D like this. Some current also flows through the load resistor like this. Due to this flow of current, the capacitor C polarities now changes. As the current is flowing like this, that is from higher potential to lower potential, the upper plate of capacitor will now be at negative polarity and lower plate will be at positive polarity, as the current is flowing like this from higher potential to lower potential. Due to this negative polarity, the thyristor T1 will be reverse bias and it will turn off, and due to positive polarity thyristor T2 will turn on. Due to this condition, the current now starts flowing through the capacitor and through the thyristor T2 like this, as thyristor T1 is non-conductive. The current also follows a path like this. Here we can see that now the current through the capacitor is flowing like this. So the polarities of the capacitor now will be again changed, that is upper plate positive and lower plate negative. Due to this negative polarity, the thyristor T2 anode terminal will be at negative polarity, that is thyristor T2 will be turned off. Now due to this negative polarity, thyristor T2 will turn off. Now both the thyristor T1 and T2 will be turned off. This is the actual process and the difference between class C and class D commutation technique, that we have actually turned off the two thyristors here. Here in this condition, neither the thyristor T1 is conducting nor the thyristor T2 is conducting, because here actually we modified the class C commutation circuit by including a inductor L and a diode D. Now we will look around the waveform of this circuit. Here we will see the waveform of impulse commutation, that is our class D commutation. This is the time instant during which thyristor T1 is turned on, and this is the instant during which the thyristor T2 is turned on by applying gate pulses. This is the waveform of capacitor. As the capacitor polarities are changing alternatively, so we can see that the capacitor polarities here, this is the positive polarity, this is the negative polarity, this is again positive polarity. As the polarity of the capacitor is positive, the thyristor T1 is actually at the forward bias condition and thyristor T1 will be turned on. As there is negative polarity, which actually this negative polarity act as the negative polarity for thyristor, but it will act as positive polarity for thyristor T2. So at this instant thyristor T2 will turned on just because of this negative polarity of capacitor. Actually this negative polarity is the polarities of the plate which are changing alternatively. Now we will see the waveform of current through the thyristor T1. This is the current waveform through the thyristor T1. As we can see that thyristor T1 is turned on at this instant. A heavy current flow. This heavy current is due to which initially the thyristor T1 was actually across a battery V and a capacitor C. So the current through the thyristor T1 was flowing because of battery V as well as capacitor C. So a heavy current flow through the thyristor T1 initially. After that the thyristor, actually the capacitor polarities changes. Now the current is bit constant, that is current flowing through the thyristor T1 just because of battery only. Initially it was flowing because of battery B and capacitor C. So this is the current waveform of thyristor T1. Now we'll move towards the voltage waveform of thyristor T1. This is the voltage waveform. As we can see that during the conductive mode, that is when it is conducting, current is flowing, there is zero potential drop. During conductive mode, thyristor T1 offers zero resistance, that is zero voltage drop across it. When it is not conducting, during this phase and during this phase, a voltage develops across it, that is potential develop across it. So this is the waveform for voltage through the thyristor T1. This is the current waveform for thyristor T1. This is the capacitor voltage which is alternatively changing. Now we will left with the current waveform of load. We have just discussed the current and voltage waveform of thyristor T1, which is our main thyristor. So we will not, actually this waveform will not show the current and voltage waveform of thyristor T2, which actually act as a auxiliary thyristor. Now here is the current waveform. As you can see that current is actually flowing through the load just because of the thyristor T1, it is constant all around, and when thyristor T2 is flowing, that it again shoots up, due to which the current is actually flowing through the load just because of capacitor C and as well as battery V. After that both the thyristor will turn off at this instant. So this is the waveform for class D commutation technique.